So, the good news about solving absolute value inequalities is it is very similar to solving absolute value equations, right? Just like when you first had solving equations, right? Not long after that, you probably learned how to solve inequalities. And it was very similar, right? But with just, not exactly the same, but similar kind of stuff, right? So, let's see here. Okay. Yeah, we'll go to just the basics here first. So let's first of all just talk about some basics. All right. So for example, so we should remember, right, that absolute value means distance from zero, right? Distance from zero on a number line, okay? So when we had absolute value of x equals 3, right, then we wanted to figure out what numbers were 3 units away from 0, okay? And that was 3 and negative 3 when we had the equation, right? But now we have this absolute value inequality, and we want the distance from 0 of x, we want it to be more than, right, greater than 3 units away from 0. Well, if we think about a number line, okay, sketch number line here. There's 0. I'll put like 3 there and negative 3 there. Okay? To go more than 3 units away from 0, okay, to go more than 3 units away, I would go out 3 units. And then which direction from that 3 do I need to go in order to get greater than 3 away from 0? Which way should we go to get numbers that are bigger than 3 units away from 0? To the right, right? To the right, okay? So in other words, we're going to go to the right of that 3. Okay? Are we going to include the 3 in this solution set here? No, because 3 is exactly 3 units away, and there's no equal to there, so we're going to put an open circle there. What inequality is this part of the number line equal to, or the same as? How could I write this part of the number line as an inequality? It would be x is greater than 3, yeah. Like that, right? X is greater than 3. That's what that part of the number line represents. Okay. However, if I want to be more than 3 units away, I can also go 3 units away in this direction, right? Negative 3 is also 3 units away from 0. And if I want to be more than 3 units away from 0, which direction should I go from negative 3? To the left. So again, open circle and then shade to the left. Okay. What would be the inequality that describes this section that we have here? X is less than negative 3, right? Okay. So, our original absolute value and inequality, like the equation, right? Like when we have an equal sign here, it splits into 2. And like the equation, right? One of the 3's stays 3. One of the 3's becomes a negative 3. Right? Okay, so we have the opposite signs there. Okay, like the equation. Okay. The one difference here from the equation, though, is that in the equation, right, an equation doesn't really have a direction, right? The equal sign kind of works the same way both ways, right? But here, our inequality sign flips around. So one inequality stays exactly the same one when the 3, stays the same as well. So it becomes greater than 3, right? Stays the same. But this one, it flips, right? The sign changes and the absolute value, the inequality symbol changes too. Okay? And this is our result. Okay? So that's how we're going to solve these absolute value inequalities. Okay? One will stay the exact same sign, same direction of the inequality symbol. The other one will be the opposite, right? Positive 3 becomes a negative 3, the greater than becomes a less than. Okay? And that's how we're going to solve these inequalities. So let's try another one here. Right, absolute value of x is less than or equal to, I don't know, 4. Okay. Here we start with greater than. So from that greater than, we had to go out, away from our 0. So let's talk about less than or equal to 4. Okay, so if I go out 4 units, but I want my distance here, right, again, this is distance from 0. If I want my distances to be less than or equal to 4 units from 0, so here I'm 4 away. If I want to be less than 4 units away from 0, which direction do I need to go? From here? Left. Left, correct. Like this. Okay, and again, I'll put a solid dot here because we have the equal to now. We're going to include that 4. Right? If I put in 5, right, 5 is more than 4 units away from 0, right? If I try it, just 5, absolute value 5 is 5. That's not less than or equal to 4. But I can also go 4 units away this direction. But if I want to be less than a distance of 4 from 0, which way should I go from here? Right. To the right. Okay, so solid dot to the right. And so for a less than or equal to 4, we're going to be between that negative 4 and 4. Okay? That will keep us less than 4 units away, right? We'll be limited 4 units to the right, and we'll be limited 4 units to the left. Between those two, that kind of creates boundaries. So this inequality, okay, x is between them, right? We'll put less than or equal to 4 like that, and less than or equal to negative 4 like that. You can still split them up if you want to. So in other words, you could also say, okay, so that same thing we talked about over here in this example works as well, right? So where we keep one inequality the same, and the other inequality we flip the direction, right? So the less than or equal to becomes greater than or equal to, and the positive 4 becomes negative 4. And though this one is an and inequality, in other words, it's where these two overlap. Okay, it's a compound inequality. Okay, whereas this one here is an or inequality, or because these don't ever overlap. All right, so it's either this one or this one. Okay, this one we say the and to show that it's where these two overlap. Okay, but the direction and stuff still stays the same, or the idea of how the direction changes, right? One inequality stays the same. One inequality flips the sign and flips the positive or negative. Okay, works there too. Okay. Questions so far? Okay. So let's have you try. Let's have you. Well, I mean, I guess I can have. Yeah, no, I'll have you try one. So you guys try one here. I'll give you 2 to try. So let's do. Okay, so try those 2. Try those 2 there. Test tomorrow. Test is tomorrow.
Is this on the test?
This will be on the test, yes.
Oh, sick.
Questions? Yes, this
If we do better on the test, we change our quiz.
Say one more time, sorry.
If I do better on the
If you do better on the test, that will replace your quiz grade, yes. Okay. Thursday.
Mr. Waymark, are we percent?
Yep. I'll ask you guys.
Because it's my ears were. That's wrong.
Actually, I think I'll make the test Wednesday.
Wait,
Yeah,
what?
I'll make the test Wednesday.
So we're doing tomorrow then? We're not learning any new content?
Tomorrow, correct? Yeah.
Wait, so we're not learning anything new?
Tomorrow, no.
So tomorrow we can like review.
Tomorrow's all review.
Tomorrow's all review day, correct? Yes, yes,
Thank you.
yes, yes. Unless you never learned in the first place, I guess it'll be new to you then. But yes, no, there won't be new content. Okay. So yeah, we'll do test Wednesday. So. Does that break anybody's heart?
No.
Is anyone's heart broken by that?
No, not very
My
much.
what?
It's like,
My heart is
no.
By the test being pushed back a day?
No, it's really helpful. Not stress.
My heart.
That I might just not.
I can let you stress for longer now.
Yeah,
Yeah.
of course. I have more time to study and everything.
Mm-hmm. Very good. All right, let's see how we did then. Yeah, we'll do that. Sienna, were you able to get anywhere here with this first one?
Is it X's?
Well, just tell us what you did first. We'll go over the answers, but go ahead and just work us through the problem here. What did you do
I
first?
don't know if I did it right, but I did minus 15.
Yeah, that's exactly what you want to do first there. Just like we did with the equations, right? We want to subtract that 15 from both sides. And so we get absolute value 4 minus x is greater than 6. Okay?
Oh, I just didn't subtract.
That's fine. But then would you be able to tell us what should we do from here then?
Well, since it was 4 minus x,
Mhm.
could you switch it around and do x minus 4?
So we could make it negative x plus 4 if you wanted to switch it around, yes.
Okay, so then that's what I did.
Okay, so you made it, so you kept in the absolute value, made it look like this? Like this kind of is what you're thinking?
Because don't we have to get 2 answers?
Yes, right. So the way we're going to do that is we'll then, once you isolate the absolute value, okay, you're going to break this up into 2 inequalities. One where, oops, I don't need that absolute value anymore. Negative x plus 4 is greater than 6. So one stays the exact same, just drop the absolute values. The other one, the inequality sign should flip, as well as the sign of that 6 there. Like so. Okay?
Subtract 4 from the side.
And exactly right. Then we'll subtract 4, so you get negative x is greater than 2, and here negative x is less than negative 10. And then, 1 second there. And then divide everything by negative 1, right? So we'll get, now, when we divide by a negative in an inequality, what do we have to do with our inequality symbol? Flip it around, right? So we're going to divide here, not because of something to do with absolute values and stuff, it's just because when we solve an inequality, right, and we divide or multiply both sides by a negative number, it's got to flip around. So now it becomes x is less than negative 2. And this one here becomes x is greater than 5. Okay, now what do you want to see? Sorry.
Why did the sign split between minus x plus 4 is 6 and then minus x plus 4? Like, why did
So why do we have this separate? Why is it this?
Yes.
So if you again think back to what we're being asked here, right? We want the distance of this thing to be more than 6 away from 0.
Yeah.
Okay, so this thing here, right, if you think about your number line, okay, to be more than 6 away from 0 means, here's 0, right? If I go to 6 out this direction, if I want to be more than 6 away from 0, I have to go this way. So in other words, I have to be greater than 6. So there's the greater than 6, right? If I go 6 in this direction, I'll be at negative 6, but to go further than 6 away, I have to go less than the negative 6, right, on the number line, and so that's why we got a less than negative 6, okay?
Why did that 10 become
I don't know. There you go. Yeah, it should be a 10. Sorry about that. Okay. And so these are our two inequalities, okay? And this is an or because they're going different directions. They don't overlap. Or. All right. So Sienna, you feeling okay on that one now? You kind of see what to do? Okay.
Some shock components and then I messed it up.
Yeah, because I was like right at the beginning. Yeah, understood. Good.
How do you know if you should write and or?
How do you know if to write and or? It has to do with, so in this case, right, our inequality here, we want to be more than 6 away from 0. So two different directions, okay? They're not overlapping at all, right? So since you're going two completely different directions, you want this one or this one, okay? But when we get to this one, okay, which, Christian, you want to go ahead and tell us how did you break it down into two inequalities? Were you able to do that, you think?
Oh no, I got halfway through. I stopped.
Okay, so it should be 2x plus 3 is less than or equal to 5. Again, the absolute value is isolated in this case, right? So like Sienna had us subtract 15 here first, which was exactly right. We want to get the absolute value by itself. Here, the absolute value is already by itself. So we'll break it into two inequalities. One where it's the exact same, and one where we flip the sign and flip the sign, right? So the, darn, I keep writing that out there. I don't want to do that. Okay. Okay, so we get these two inequalities. Sorry about this one. Okay. And then we just solve. So we get 2x is less than or equal to 2, x is less than or equal to 1. And here we get 2x is greater than or equal to negative 8, so x is greater than or equal to negative 4. Okay, so now, Natalie, right, your question earlier about this problem, right, why did we, go two different directions here, why do we have two different inequalities? Here we're trying to stay less than or equal to 5 away. So if you think about your number line again, right, again, put 0 in the middle just because there, okay? To go less than or equal to 5 away, well, I can go 5 away in this direction, and if I want to be less than 5 away, I'll be going this way. But I can also go 5 away in this direction to negative 5, and if I want to be less than 5 away, I will go to the right. So in other words, we're between that negative 5 and 5. So less than or equal to 5, but greater than or equal to the negative 5. And this creates, Christian, the compound inequality, because now we're between the negative 5 and 5, so it's an and where they overlap. Okay, so x is less than or equal to 1, and x is greater than or equal to negative 4. Bless you, and bless you. We can put them all together. Negative 4 is less than or equal to x is less than or equal to 1. Okay, so either one of these is an acceptable answer. You can't do that to this one because the signs don't go the correct direction there, but in this one you can put them the same way like that. Combine them together. Okay. Questions on any of that? No questions? Question? Okay. All right, let's look at one more inequality here. Okay. You can also solve by graphing. Also solve by graphing. Okay. So I'm going to sketch the graph of this over here. Okay. I'll graph the absolute value in blue. I'll graph the 4 in red. Just to have some contrast there. Contrast, I should say. All right, so this would be a good review, right, of graphing inequalities. What kind of transformations do we have here for our inequality?
Left.
Okay, left 3,
Up 1.
up 1. Yeah, left 3, up 1. Okay, right, that's our shift left 3, shift up 1 there. So left 3 from the origin, up 1, there's going to be our vertex. Okay, the A value, our A parameter is what? What value is there?
1.
Yeah, 1, right? 1. So we don't need, it's just going to be up 1, right 1, up 1, right 1. It's kind of like our slope there. There's no vertical stretch or shrink. So it's just going to be up 1, right 1, up 1, right 1, up 1, right 1. And I can keep going, I guess. Up 1, right 1, like that, and so on and so forth. So there's that side of our absolute value. Okay? And then I can also, of course, by symmetry, instead of going up 1, right 1, I can go what other direction? Up 1, left 1 for the symmetry, right? And so then up 1, left 1 there, and up 1, left 1 there, like that. Like so. And then what's the graph of 4 going to look like? Bless you. What's 4 going to look like when we graph that? Natalie?
A line to 4.
Yeah, a line through 4. And what 4 though? The
Y.
Y value 4, exactly right. 1, 2, 3, 4. And I think this was supposed to intersect. 1, 2, 3, 1, 2. I think it's supposed to intersect right there. Okay. So if this were an equation, so let's kind of review real quick. If this were an equation, if I wanted to know when the absolute value of x plus 3 plus 1 was equal to 4, where would I look on my graph to see where these two things were equal?
Where they intersect.
Where they intersect, exactly right. Okay, and specifically, we would just be interested in the x values where they intersect. So at negative 4 and at 0, okay, where they intersect. But I'm not interested where they're equal. I want to know where the absolute value is greater than 4. So how can I see that visually then? How can I see where the absolute value, this absolute value graph here, is greater than 4? What am I looking for, Natalie?
Shape the top part.
The part where, right, where the blue, right, is above the red, right? We want to know when is this greater than this. So it's for the intervals where these x values here, the x values here, where the blue part is bigger than the red part. So, for example, here, okay, for x values greater than 0, right, the blue part will be above the red part, right? The absolute value will be above 4. So for x values greater than 0, or for x values that are what? Less than what x value? The blue graph here will be above the red graph for x values that are less than what? 1, 2, 3, 4, 5. Yep, negative 6. Like that. Just like that. So there's us solving it right here. Okay, it's this part of the interval right here. It's this part of the graph and this part of the graph right there. And we just need to describe the x values. We don't know the y values. And of course, if you solve this by hand, right? So if we subtracted 1 on both sides there, you get absolute value x plus 3 is greater than 3, right? Break it into two inequalities. X plus 3 is greater than 3. X plus 3 is less than negative 3. And then you solve, you get x is greater than 0. And you get x is less than negative 6. Right? So it works with the solving too. Of course, right? It should work with solving as well. But there it is. You get the same answer. All right. Okay. So, I think that's all I've really got for you there. Oh, I guess I should also mention, right? Just like our equations, be on the lookout for whether your inequality makes sense. Okay, so for example, I'll put this in blue, I guess. Don't have to say it too. So, let me just put a little side note here. Watch out for impossible inequalities. Okay. For example.
Sorry to interrupt.
All done?
Yes.
Very good.
There you go.
Thanks, sir. Cat-like reflexes. Okay. This inequality is impossible. Why? Yeah, we can't be less. Absolute values will never be negative, much less than a negative number, right? Okay, less than a particular negative number. So this is just, it's not possible. So be on the lookout for that, okay? Any sort of the absolute value of something, okay, less than or less than or equal to a negative number, you know that's not possible. Okay? Watch for zeros, too. Is this possible?
What if each go the same number, the same answer?
Well, is it possible for an absolute value to be less than 0?
Yes, it's a negative.
Will absolute value ever be negative?
Yes.
No, right? So this also is impossible. Okay? But if you put an equal to, now it's possible, right? If I put less than or equal to 0, yes, it's possible for an absolute value to equal 0, but it's not possible for an absolute value to be less than 0. Okay? So watch out for those impossible inequalities too. Okay? All right. So I think I'm going to stop there and give you guys an assignment here. Okay? So you guys have got a good amount of time to work on the homework, or you can also start working on the review if you prefer to do that instead. The rest of the time here I'll give it to you. So in section 2.3, page 67, numbers 7 through 10. Let's do 13 to 16. Um, 19. Talking about squirrel's age there. Very good. right, we'll stop there. Okay. Okay, there you go. So originally I had meant to try and squeeze this in with equations, but I feel like maybe that's going to be too much to try and squeeze in with equations. So I'll correct that in the future. Oh, yeah. Get your copy. You're welcome.
I have a question on one of the review things.
Okay, I'll be right there. 1 second. Let me just finish circling this. All right, so the rest of the time is yours. Please use it wisely. You have 25 minutes. That does not mean you can sit there and play on your phone for 25 minutes, right? Let's get some actual work done. So either I want you to be working on this homework or the review, okay? Or the review, okay? Certainly no one would want to waste their entire class period playing on their phone. Okay. Yes, absolutely, yeah. Or if you want to plug in there, wherever's most convenient for you. Okay? Yes, Lynn. Good question. It would be an or. Since we're trying to be more than 3 units away, that means we're going to go this direction and then the opposite direction. So it's going to be an or inequality there. So yeah, now
How do they access the online?
go to your FCPS bookmarks and go to my HRW, and then I can.
On there.
What's that?
Is it?
Yeah, and so you want Algebra 2, of course. Yep. And then you want the student edition, not the interactive student edition, just student edition. There you go. And then go to Unit 1, and then it's like Chapter 2, though, and then Section 3. You should see it from there. Yes. Let me see. If some people still need to take it. So Max took it. Brooks didn't get today. Yeah, I'll give it back to you. That's fine. Yes. Or you just want yours back right now, right? Yeah. Okay. Yeah. Camera punch back. Okay, I'll take those. Thank you. You're welcome. All right, let me see. Good question. You said today? Question?
I have a question about the
Okay, 1 moment, please. Work.
I saw that.